Dear students, in last class we completed the direct form 2 structure realization of IIR systems. Today I will take up cascade form realization of IIR systems. In this realization, procedure, the transfer function h of z can be expressed as a product of a number of first order or second order sections as shown in equation 5. H of z equal to y of z upon x of z, that is equal to h1 of z into h2 of z into dash 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 hm of z. Symbolically we can write the product of these m number of transfer functions as product of hi of z, where I varies from 1 to m. Let us call this as equation 5 now. The individual second order or first order sections can be realized. Either in direct form 1 or direct form 2. Structures. The overall system is obtained by cascading Cascading means giving output of first system as input to the second system, output of second system as input to the third system, and so on. The individual sections as shown in figure below. The number of calculations and the memory requirement depends upon the realization of individual sections. So here you can see the cascade form realization of IIR system. Here the output of first system is given as input to the second system. To the first system, input is the input to be given to overall system. The output of last system is the expected output of overall system. Now we will take one problem based on cascade form realization of IIR system. Obtain the cascade form realization structure of the LTI system governed by the equation y of n equal to minus 3 by 8 y of n minus 1 plus 3 by 32 y of n minus 2 plus 1 by 64 y of n minus 3 plus x of n plus 3 into x of n minus 1 plus 2 into x of n minus 2. Given y of n equal to minus 3 by 8 y of n minus 1 plus y of n minus 2 plus 1 by 64 y of n minus 3 plus x of n plus 3 into x of n minus 1 plus 2 into x of n minus 2. Taking Z transform of y of n, we get y of z equal to minus 3 by 8 into z raised to minus 1 into y of z plus 3 by 32 into z raised to minus 2 into y of z plus 1 by 64 into z raised to minus 3 into y of z plus x of z plus 3 into z raised to minus 1 into x of z plus 2 into z raised to minus 2 into x of z. Now I will take all the y of z terms on one side and x of z terms on other side. Y of z minus of minus will become plus here. 3 by 8 z raised to minus 1 y of z minus 3 by 32 z raised to minus 2 y of z minus 1 by 64 z raised to minus 3 y of z equal to x of z plus 3 into z raised to minus 1 into x of z plus 2 into z raised to minus 2 into x of z. In the next step, I will take y of z common outside on LHS and x of z common outside on RHS. Now, y of z upon x of z equal to h of z, that is equal to 1 plus 3 into z raised to minus 1 plus 2 into z raised to minus 2 by 1 plus 3 by 8 z raised to minus 1 minus 3 by 32 z raised to minus 2 minus 1 by 64 z raised to minus 3. Considering numerator polynomial, that is 1 plus 3 z raised to minus 1 plus 2 z raised to minus 2 equal to, from this polynomial I will take z raised to minus 2 common outside. So I can write now z square plus 3z plus 2. This bracket is quadratic polynomial in z. Finding its zeros, we get z plus 1 into z plus 2. Now splitting this z raised to minus 2 as z raised to minus 1 into z raised to minus 1, we can write z raised to minus 1 into bracket z plus 1 into z raised to minus 1 into z plus 2. Taking z raised to minus 1 here in this bracket, we get 1 plus z raised to minus 1 into 1 plus 2z raised to minus 1. Now we will consider denominator polynomial. So write here, considering denominator polynomial. One plus 3 by 8 z raised to minus 1 minus 3 by 32 z raised to minus 2 minus 1 by 64 z raised to minus 3. From this cubic polynomial, I will take, from this denominator polynomial, I will take z raised to minus 3 outside. Inside the bracket, I will have z cube plus 3 by 8 z square. Here I am having minus, so I will change this to minus 3 by 32 z raised to 1 minus 1 by 64 bracket complete. Using calculator, you find the zeros of this cubic polynomial. Get z raised to minus 3 inside the bracket, z plus 1 by 8 into z plus half into z minus 1 by 4, where 1 by 8, 1 by 2 and minus 1 by 4 are the zeros of cubic polynomial in the bracket in above line. You can find out these zeros by using your calculator. Now once again I will split this z raised to minus 3 and rewrite z raised to minus 1 into z plus 1 by 8 into z raised to minus 1 into z plus half into z raised to minus 1 into z minus 1 by 4. Taking z raised to minus 1 inside the bracket, we get 1 plus 1 by 8 z raised to minus 1 in one bracket and 1 plus z raised to minus 1 into half in another bracket, and similarly here we get 1 minus 1 by 4 z raised to minus 1. Now I will rewrite h of z, but now I will write it as the product of their factors. But now I will write numerator and denominator as the product of their respective factors. So in the numerator we will be having 1 plus z raised to minus 1 into 1 plus 2 into z raised to minus 1 divided by 1 plus 1 by 8 z raised to minus 1 into 1 plus half z raised to minus 1 into 1 minus 1 by 4 z raised to minus 1. From h of z here now we can get h1 of z, h2 of z and h3 of z. Let us take h1 of z equal to one upon 1 plus 1 by 8 z raised to minus 1. h2 of z equal to 1 plus z raised to minus 1 upon 1 plus half z raised to minus 1. And h3 of z equal to 1 plus 2 into z raised to minus 1 by 1 minus 1 by 4 z raised to minus 1. Now I will call h1 of z as the ratio of, now I will write h1 of z as y1 of z upon x of z, that is equal to 1 upon 1 plus 1 by 8 z raised to minus 1. Now cross multiplying, we get y1 of z plus 1 by 8 z raised to minus 1 y1 of z equal to x of z. Therefore, y1 of z is equal to x of z minus 1 by 8 into z raised to minus 1 y1 of z. Now we can implement this as direct form 1 or direct form 2 realization structure. Direct form 1 realization of h1 of z. X of z is input. From this we have to subtract minus 1 by 8 times z raised to minus 1 y1 of z. Let us say y1 of z is here. Delay this by one sample. Delay this y1 of z by one sample. Then multiply it by a gain of minus 1 by 8. Now it is direct form 1 realization of h1 of z. The direct form 1 realization and the direct form 2 realization of h1 of z will remain same, because here we are having only one part, that is the RHS part. If you bring this here, you don't have anything to take it to the RHS. If you bring RHS part to the LHS, then you don't have anything to take to the LHS. Then you don't have anything to take to the RHS. Now let us take H2 of Z equal to 1 plus Z raised to minus 1 upon 1 plus half Z raised to minus 1. Cross multiplying, and this is equal to what now? To the second system in cascaded form, that is H2 of Z. Input is the output of first system, that is Y1 of Z, and the output of second system is Y2 of Z, which will be input to the third system. So here we have to write H2 of Z as Y2 of Z by Y1 of Z. Now cross multiplying, we get Y1 of Z into 1, that is Y1 of Z only, plus Y1 of Z into Z raised to minus 1, that is equal to 1 into Y2 of Z, that will be equal to Y2 of Z only, that will be Y2 of Z only, plus half into Z raised to minus 1 into Y2 of Z. Simplifying for Y2 of Z, we get Y2 of Z equal to Y1 of Z plus Y1 of Z into Z raised to minus 1 minus half into Z raised to minus 1 into Y2 of Z. Right. Now we will realize this in direct form 1 structure. Show here one adder, because we need to add Y1 of Z and Y1 of Z into Z raised to minus 1 and tap Y1 of Z at this point, and to that tapping you connect delay box or delay element. Here gain is 1, in the gain box you show 1. Now add these two. So here output is now Z raised to minus 1 into Y1 of Z, and here output is Y1 of Z plus Z raised to minus 1 into Y1 of Z. Now from this summation we have to subtract half z raised to minus 1 into y2 of z. So show here one delay box, and then in the gain box you show minus half and show here one adder. Now you get here y2 of z. Now this y2 of z is input to the third system, that is h3 of z. So what we will do now is we will take h3 of z equal to and h3 of z equal to one plus 2 into z raised to minus 1 by 1 minus 1 by 4 into z raised to minus 1. Cross multiplying we get h3 of z, h3 of z is equal to what? h3 of z is equal to y3 of z upon y2 of z, because input to the third system is output of second system. This is equal to 1 plus 2 into z raised to minus 1 upon 1 minus 1 by 4 z raised to minus 1. Cross multiplying we get y3 of z minus 1 by 4 z raised to minus 1 y3 of z equal to y2 of z plus 2 into z raised to minus 1 into y2 of z. Now to simplify for y3 of z, y3 of z will be equal to y2 of z plus 2 into z raised to minus 1 into y2 of z plus 1 by 4 into z raised to minus 1 into y3 of z. Now let us implement this in direct form to realization structure. Output is y3 of z. We show that here. Input is y2 of z. Show that here. To y2 of z I have to add z raised to minus 1 into y2 of z into 2. So tap y2 of z, delay it by one sample, then multiply the output of this gain, then multiply output of this delay box by 2 and then add it to y2 of z. Next, to the sum here. What is the sum here? Sum is y2 of z plus 2 into z raised to minus 1 into y2 of z. To this sum you have to add 1 by 4 times z raised to minus 1 y3 of z. For that, let us have one sample delayed version of y3 of z and then multiply it by 1 by 4. Output of that multiplication element you give as input to the adder here. Now y3 of z is available to us. Now if we connect h1 of z, h2 of z and h3 of z such that output of h1 of z is input to h2 of z and h2 of z output is input to h3 of z, then we get cascaded form of realizing the IIR system. Let us do that now here. For this diagram you write here direct form 1 realization of h3 of z, and below that we will show cascade realization of the system. So first, system will have input as x of z, right? There is one adder output is y1 of z delayed by one sample z raised to minus 1 and the gain is minus 1 by 8. Now this output y1 of z is input to the second system. In the second system we are having that is in h2 of z we are having this block diagram. So we'll show this system connected to y1 of z of first system. That is minus half here. Here we get y2 of z To this y2 of z, this point from h3 of z we will connect. So we will have here z raised to minus 1 gain as 2 and one adder here. Next I will show here y3 of z and here I have to show one adder also, please correct this, plus and one delay box z raised to minus 1, one gain of 1 by 4 or multiplication with constant 1 by 4. Show it here connected to the adder. This y3 of z is what? y3 of z is equal to y of z, that is the final output of the system. Just put it in box, which means you know everything about it. So with this we have completed cascade realization of the system. Now I advise all of you to realize this system in direct form too. You take each of transfer functions h1 of z, h2 of z, h3 of z, which already you have realized in the form of direct form 1. Now you realize them in direct form 2. Do not do any calculation, just take the block diagrams and convert them into direct form 2 realization structures, and then those structures you bring and place in between x of z and y of z. That will become cascade realization of the system, with each system being represented in direct form 2. This is okay now, but each system within this big system you represent as what? Direct form 2 realization. Dear students, I will stop the class here and continue in next class with the parallel realization of IIR system. Thank you.